Hello YouTube, Mr. Angus Wangus here, and I'm not in the woods looking for Bigfoot. I've been working furiously at this wheel. I'll tell you right off the top, I hate this setup. I hate this wheel. I miss my old wheel, which I have still, and I'm going to be launching right into after this, but I've been working at this one real hard to show you guys what I've found. I've figured something out really cool, really cool. And again, it's taken me a bunch of days just to wind these coils. I salvaged the wire totally out of microwave oven secondary windings, but they're not the smallest gauge wire. They're about a 25 gauge is what I can gather. But so they're not ultra thin, you know, like with the delayed lens effect or the Thane-Hines effect, where you had to have the very thin wire, the very high impedance, very high high frequency wheel going really fast with the high impedance in order to get the effect when you short it out or dump a load across it, or put a load across the coil. Then the wheel would speed up, and I believe his input draw to his prime mover went down. Now I'm going to show the same thing. This is very cool effect, and I'm letting you know, this is what I found. I think I could easily sit on this idea and make a generator. That's what I'm going to be doing with this, is making a generator that doesn't require the prime mover at all. No circuitry, no battery, just those coils and cores and a wheel. And you'll see why I think that, or I hope you see that, because this is very cool. I'll get into the specifics of how it works, but basically I have the Edleed Skalman type PMH setup, right, with two coils on each prong. The wire I used isn't ultra thin. It's, from the microwave oven secondary, but it's about a 25 gauge is what I could figure from it, looking at it. Anyways, they're all the same. It's not the smallest wire. Got a little bit of background, about 25 gauge. Anyway, so that's the first. Although it's going to act the same as the Thane-Hines effect or the delayed lens effect, it's going to act the same way. It's going to speed up, and the input energy is going to go down to the prime mover. But that's the first main difference, is that the wire is thicker. Doesn't matter. And actually, I wound a couple coils with a very thick. I want to say it was about, it had to be like 16 gauge or 18 maybe, 18 gauge magnet wire, like thick stuff. And the wheel didn't speed up, but it didn't slow down. And the coil was shorted, or it had a light bulb on it. And that's what I'm going to be doing, is I'm going to be starting this up to show you. I'm going to explain it after, how it's working, because the way these are wired and wound is different than anyone's done. Anyways, I'll explain that. But what was I going to say? Anyways, it's a very simple setup. The first difference is that the wire thickness is doesn't seem to matter. Also, you'll notice that the frequency doesn't seem to matter, like with the delayed lens or the Thane-Hines effect, where he had to have a certain RPM. Now his wheel, and mine in the past too, when I got a little bit of that effect, had more, has his wheel and my other wheel had way more magnets on it, a lot more positions. This one only has 4 positions, which is going to reduce the frequency even more. And you'll see when it starts up, we'll have a look at that zip tie that's holding onto the shaft there. You can see it spinning, and I've counted it very quickly, 5-second interval, and then multiplied, and I got an estimation of about 150 to 200 RPM with only 4 positions. You do the math. Low frequency, low RPMs, low frequency. So low frequency, low RPMs, bigger magnet wire, which, this is really, really cool. Been getting the same effect. Anyways, I'll show the operation, and then we'll get into why it works, or how it works. So I have a 12 volt battery here, and I have a simple schematic that I'm going to show. 12 volt battery going into a pulse width modulator. Now this one's big and funky because it has variable frequency, and also because I made it. Anyways, here's the outputs here, and I have the positive going into this motor. This is from a printer that I found by the road. This all, incidentally, I was sitting there looking at it just prior to making the video, and I can honestly say that every bit, oh no, I just realized one bit on, I could easily change it to be where every bit of this is garbage. It's made out of scraps that I've salvaged, like the magnet wire was from microwave ovens that were thrown out. These coat hanger wires were salvaged. The magnets are from the microwave ovens. The motor's from the printer. I made this pulse width modulator all from scrap components entirely off circuit boards that I've collected. But I just realized that this light bulb is brand new. This is a, by the way, I believe 7 watt. This is a 12 watt automotive light bulb. This is a full wave bridge rectifier. Now I have these sets of coils, 2 wires coming out of each set, right? And they all go into this bridge rectifier. Now each set of coils also has a switch on it, right? They're all off right now, open. I want to say open circuit, but it's not. Now, I should say off the start, I just gave a hint as to the operation, but this isn't a trick or of any sort. I'm sharing information with you people, with everyone out there. But to start off with, there is no lensing of this wheel to start with, like with the aluminum pipe, getting the delayed lens effect. So there's the only drag on this system when I start it will be simply the iron in those cores, right? Which is fairly easy to overcome for anyone who knows. But lens isn't, right? The lens back EMF is not easy for especially a little tiny motor like this to overcome. And that wheel actually has a little bit of mass to it, those magnets. and the iron. But anyways, there's no dragging on the wheel at all to begin with from Lenz. I want to say that. However, each set of coils has a switch on it, right? And you'll see me flip those on. I have 2 meters. I'm not metering the output because it's not important. I'm showing the concept or the idea, right? So this is what we're looking at. Just know that there is some sort of output. The light bulb won't light up, right? From what I'm getting, but I wanted to put a resistive load on there, right? That light bulb is it's under 1 ohm. It's like 0.9 or something like that. This meter over here is set to AC volts, and it runs back here to a little tiny coil that I have set up underneath the wheel there, simply to show speed change, right? If the wheel speeds up any, the voltage is going to climb. If it slows down, the voltage is going to drop. Because I don't have a way to measure the speed of the wheel. I mean, real accurately, so why, that's the way I'm going to do it. And the only other meter I have here is set on amperes. It's measuring, it's on the 10 amp setting. And this is measuring the input directly into the motor. So it comes from the negative of the PWM into the meter here, right? Into the meter, and then out of the meter and into the motor. So we're measuring the input amps to the motor here, the prime mover, and we're measuring AC volts just as a way to measure speed change. Alright, so we'll get her going. I'm going to just give it a little bit of a flip. There we go. That was wimpy, but so it started out at about 1 amp. It was drawn. It's going to drop as the wheel speeds. It's got a little mass to it for this little motor. You can see how quickly that shaft is turning. Hopefully there's no skip, but I'm going to guess again about 150 to 200 RPMs. Now we're going to let it settle here, the input. We'll let it settle, it's probably right about there. And also the AC volts settle at 2.4 volts and 7.7. 0.77 input amps. Now I'm going to engage this first coil with this switch, and you'll hear the motor start to accelerate, and we'll look at the meters. The meters are at 0.77 and 2.34. Fluctuating in between. Here we go. I'm going to flip the switch now. There we go. You can hear the motor accelerating. We're getting more volts. AC volts on the meter. Our input amps have dropped. Still dropping. Gaining a little speed still. Okay, just so you know, that was the wimpy coil. Still climbing, maybe. I hear it. So I've closed that circuit. It's gone through the full wave rectifier and through that light bulb. And the wheel sped up. we're at 2.3, 2.4, now we're up to 2.7. The input amps dropped. Now I'm going to engage this coil, and this leads up to this upper one, right? Here we go. Have a listen. You can see the AC volts rising. You can hear it speeding up, actually quite a bit. Input amps dropping. We're up to 3.1 volts AC. The wheel's going considerably faster. And again, that energy is coming out of those coils across here, through the bridge rectifier, through the bulb. So it looks like we're settling down at 3.1 AC volts with our little measuring coil under there. And we have 0.67 amps going in. Now let's click the big boy. These coils, I should say, this has the least amount of wire in the middle, and here's the big boy. Each one of these spools has a full microwave oven secondary wound on it. So here we go. But it's not thick wire. I'm going to click her on. There we go. You can hear it humming now. AC volts are rising. Getting a little faster. See that? I mean, it's really thumping the wheel. So 3.5 volts now AC. And we're down to 0.62 amps going in. And the wheel's flying. Now, I can see that now it wasn't going fast. It's not dependent on frequency like the other effect. It's not dependent on the wire size. You don't have to have that really thin wire, and you get a really good effect, right? So I want to tell you how I did it. And I've come to this the back doorway, and it's been 3 years. I've been really having fun playing with pulse motors and things like that, and really thinking about free energy, right, in the back of my mind all the time. But I came at this through the back door, right? Of course, this last month I've been reading and learning. And finally, the light bulb went on, and it clicked in my brain, right? And I start on the build, right? I want to build it and try it. What clicked in my brain? Then the more as I'm building, and I had real problems with the secondary windings from those transformers, salvaging the wire. But as I worked away at it, I'd also look into Ed Leedskalnin's symbols and everything, right? Still studying, right? And come to realize Ed showed us this right from the start. He showed us how to do this, how I did that. And it's kind of embarrassing that it took me 3 years to figure it out. But no one else did either, so it's alright. But anyways, he told us, and I'm about to show you. I'm just going to let this run. But first I'll show you the simple schematic of what I have going on here. Well, first, Jesus is coming. You should get to know him. He's on his way back. But this is the simple schematic. So I've got the 12 volt battery. It's a 31 amp hour. It's going into the pulse width modulator. I was measuring the amps, not the volts. That's what those symbols are, if anyone's wondering. Then into the DC motor from the printer, which turns the wheel, which has alternating pole magnets on it, situated so that they turn. This is the cross section or straight on view of this, and they pass between the forks of the PMH, EDS PMH, basically 2 windings, 1 on each fork, and then tapping it for the AC. But basically the motor or rotor accelerates very well, actually, and it uses less current input, and that happens when the pickup coil energy is loaded, right? So you load the pickup coils on the PMH, and you get that effect. Now I'll show you what's going on. Now first, if you don't know what a caduceus coil is, or caduceus winding, basically that's what this is. A caduceus is 2 snakes intertwined on that pole. It's an ancient symbol, which basically tells us that this has been hidden from us, but basically slapped in our faces, right? And these symbols they use. But anyways, this is how my coils are wound. If anyone's familiar with bucking coils, a guy named JL Naudin in France did some tests on it, read his stuff, and he wired them. He connected them here. I've seen someone else short them out, right? Short here and short there, and then they have a primary and a secondary, and the secondary has no lensing on the primary, right? So that's what a bucking coil is, right? It's basically a caduceus winding. If you brought those together, they would be intertwined snakes. So if you take those bucking coils, caduceus winding, and you put it on ED's PMH bar, the U core, right? This is what it would look like. And now these coils that are on my wheel here are just like this, right? They're wound exactly opposite. Like when I wound these coils, this one goes in this hole right here. That's the start, and it goes this way. And when it ends on the other side, it comes out going that way. And this one is the opposite. It starts this way, and it ends that way. So those coils are wound in opposite directions, and that's the secret to tapping what's going on here. And this can be applied to this idea can be applied to solid state. I have other idea applications in mind, and many other possibilities for uses for this. What's going on here? You can do it solid state. You can do it here with the magnets. I'm starting to wonder if this is what Stephen Mark was doing with his TPU, because that's what I imagined as a solid state is a toroid setup. But they're wound in opposite directions. That's how my coils are wound, just like this. So this is a caduceus on a U core, just like Ed had. And I have the magnets alternating between the forks here. Right, so there's north, south, north, south, north, south, back and forth, right? Causing energy in these coils. Now, if anyone's ever tried I know I have. Putting two coils on the same core, you short the middle, right? And you check these ends, you're going to get no electricity, right? There's no electricity there. Zero voltage, no potential. But if you short both here to here and here to here, like with the bucking coil effect, where they had a primary and a secondary, but the secondary had no lensing on the primary, well, to go a step further, and I totally know now that this is what Ed did after having gotten here through the back door. I see this is what Ed did. The front door would have been easier, but Ed showed us. The back door was like full of rats. Anyways, but to take it a step further, what you do is you short it out here and here, and then you tap those, and you get an AC wave, right? And the back EMF is inverse to lens. So just like in this setup, right? There's no lensing to begin with. There's no aluminum pipe in there like I had with other experiments. Now they are shorted out from the beginning. They were shorted out, but they had no lensing on the wheel for the reasons that we just talked about. They're shorted out, and there's no, well, technically no electricity, right? And there's no lensing back EMF to slow the wheel down. I promise you, and I know you're going to try this. I hope you do, because I'm going to get my big wheel going. Now that I've shown you, I'm scrapping this. This is garbage. I hate it. I can't wait to scrap it, actually, and get my big wheel out, 2 magnets thick, and all the way around the wheel. Actually, both wheels. Cover the circumference of both wheels with these U's and tons of wire, and it'll drive itself. And you pull it with a ripcord and it'll drive itself. I see it coming. Or, you know, your output eventually is gonna now I could turn this down. I could turn the PMH down and get the AC. Or wait, I could turn the input down and let the AC volts drop to their original voltage before I engage the coils, and then flip all these switches all at once, disengage the coils from the load, and the wheel will almost stop. So I mean, just these 3 really crappy this crappy setup right here with lots of losses, bearings, there's frictions, there's everything. It's garbage, and it's made out of garbage. But that's where I'm going with this. Is I'm gonna make a wheel that not only makes free energy, but like drives itself without a prime mover, and it's gonna be really cool. And I think that's how Ed's flywheel operated. Now I still think that he got a homopolar effect added to his setup, but that's another thing. But this is it. That's the way you tap it. Just short them out, and having them shorted out on the wheel like that doesn't impose a lens effect on it at all. To begin with, right? It's just the iron. Again, for the reasons we talked about. But when you tap these 2 coils in between here and put a load on there, you're going to get an AC current, right? Voltage. Current. I've run each one through its own bridge rectifier with the switch, and you know, this one gets 0.1 amps. That one I don't even know. I just made it today. That one 0.6. No, this one was 0.1, and that one was 0.6 or 7. Either way, it's free. But there you go. That's how you do it. And by the way, here you go. This is what I was going to say before. Ed showed us right from the start the covers of his book, 2 of his books. This is on the one cover, and he's showing us how the 2 coils are wound in opposite directions, right? And actually, he has connections on either end. But he goes a step further, and in his other book, he doesn't show the winding directions, but he shows that this ends are connected and these ends are connected. And actually, with the little upward point there, would suggest that he's implying that's where you tap it, just like we were talking about here. But anyways, this is my new idea I'm on to, and hopefully everyone else sees, you know, how big of a deal this is, and tries it themselves. Again, it's not depending on the wire size. It's not dependent on the frequency. So it's much more attainable, much easier to get to use to your advantage. And that's what I'm gonna do, is I'm gonna get my big wheel filled with these things, and I'm not even gonna need a prime mover. And I hope everyone does that. But give me your feedback. This video, I hope goes viral. I put a lot of time and effort into this, and I'm really excited about this. Now, in the past also, people have asked about donating to my cause, and that would be cool. I thought about it. In the past, I'd never had a donation link, but I thought about it, and I would invest if anyone ever did that, I would invest it into my idea here, because it would definitely make things go faster. I don't have a whole lot of extra cash, to tell you the truth. I make everything out of garbage, out of things that people throw away. So I have a lot of microwave oven transformers, but it's been rough salvaging the wire out of them. Some of them go good, some of them go bad, and when they go bad in the middle of winding it, you really, came close to a snap session. Oh, it's just trying, you know. Anyways, I have a link for donations now on my channel. I'll leave it here at the bottom of the video. Hopefully that you spread and share this video with everyone, the ideas that we talked about, how it works. Share this, please, with everyone. The more views, the better, right? But because I have offered up a big idea to you here, I see it. Hopefully everyone appreciates it. But either way, something like that would help things go faster for me. If I had you'd say a spool of wire, I could make something very quickly. But anywho, there you go. This is very, very cool. I'm so excited. Now after fighting with the wire for a while here, I'm ready for a break, so I'm going squatching. I'll be in the woods. There's big woods I'm going to check out tomorrow. But there you go. There's something new to think about. Hopefully everyone appreciates it. Sorry the video's so long. There's a lot to cover. Probably left a lot out as usual. Take her easy. Leave a comment. Oh, I'll have my comment. I'll be screening my comments, just so you know. Like my other free energy demonstration video, I had to do that. But we'll see how it goes. Most comments will get, you know, approved, but I'm not interested in nonsense. We'll just put it that way. I'm getting better anyways. But anywho, just so you know, there you go. And I'll talk to you later. I'm going squatching, and I'm going to rip this apart and start working on my big wheel. I would start working on a big version if I was you. This works, and it's really very cool. Anyways, there you go. Long video. Take care.